Okay, so I think of test 2 as really being about 3 main topics: sampling distributions, confidence intervals, and hypothesis tests. So let's talk about sampling distributions first. So the key thing that makes this different from a regular distribution is that you're talking about the distribution of statistics that you would get from many different samples. So this is really different from looking at a distribution of individuals. So if you're talking about categorical data, you would be sort of assuming that you know what your parameter is. So in this case, it would be P for the population parameter. And you're imagining taking a lot of different samples and calculating the sample proportion each time. So it's going to be centered at the true proportion. It's unbiased, but there's going to be some amount of variation in those. So the standard error, the formula given here, tells you how much you can expect those sample proportions to vary. And we also have information about whether or not it's bell-shaped. So this really just depends on the sample size. So deciding whether it's bell-shaped, you have to check the sample size condition. And for proportions, you want to check that n times p is at least 10 and n times 1 minus p is at least 10. Okay. We can also do something similar for quantitative data. So quantitative data is summarized with means. So it's centered here at the population mean. And if you took many different samples, you'd get a lot of different y bar values, a lot of different sample means. Okay. The spread is given by the standard error formula. So that's part of your reference sheet. And then to decide if it's bell-shaped, again, you need to check the sample size condition. And there's actually 2 different ways to meet these. One is just that your sample size is at least 30. So if your sample size is nice and large, your sampling distribution will be bell-shaped and you don't have to worry about it. But if you have a small sample size, the other way that you can meet it is to see if your data are nearly normal. So you would have to make a graph and make sure that it looks pretty unimodal and symmetrical.